So we're gonna transition to our last speaker today. We're good. All right. So our last speaker is Anhai Doan, which is a BILAS Distinguished Achievement Professor and Gurdinar Soy Professor of Computer Science at the University of Wisconsin-Madison. His interest covers database, AI, and web with a current focus on data integration, data science, and machine learning. And I received the ACM Doctoral Dissertation Award in 2003, a Career Award in 2004, and a Sloan Fellowship in 2007. He co-authored Principal Data Integration, a Morgan Kaufman textbook in 2012. And I currently works as a VP of Technology at Informatica. He has also served on SIGMOD Advisory Committee and SIGMOD Executive Committee and co-chaired SIGMOD 2020. Let's welcome our next speaker.
Thank you. So I guess I should share my screen, right? And just move on with the presentation. So
yes.
Yes. Okay. Okay. So thank you for that kind introduction. So today I'm going to talk about making data integration more accessible for citizen data scientists. So this is joint work with a lot of students and colleagues. So the main message of my talk is as follows. Data integration has been known for a long time to be a major part of data science pipelines. There are very few data integration tools today that are good for citizen scientists. And so for the past 6 years, we have been developing a few such tools, Magellan, CloudMatcher, Columbus, that I'm going to talk about in some more details. We have had some success. We got some award-winning research. Our tools have helped many domain scientists, journalists, students, data scientists at companies. We had a startup that was acquired by Informatica, and many tools are now being developed at Informatica. But there's a lot of work remains to be done to fully realize the potential of this. So what is data integration, right? So if you're going to do a data science project, typically you will start by extracting data from a bunch of different places, like a relational databases, from text. Let's say you have extracted these 2 tables, and then now you actually need to clean the data. Maybe this value here is not 35.1, it is only 35. You need to do the matching. You need to realize that name here is the same as the C name and location is the same as the address. You also need to recognize that upper here is the same as the upper incorporation down here. After you have done all of this, you could match, merge, combine the data into a single clean data set. And that is where you can run machine learning models and you could do data analysis and answer questions like this, right? So basically you have 2 steps. The last step is called data analysis. The first step is called data integration. This is also called data wrangling, data preparation, curation, and many other names. This first part is actually very, very time consuming, often consume up to like 80% of the effort. And so now it is the focus of a lot of attention. Unfortunately, today, there are still very few data integration tools that would be good for citizen data scientists. Most of the tools are actually standalone monolithic tools developed by data integration companies, and they are basically for enterprise customers who paid like 30, 40,000 or even more just to use them. So they are very expensive. They are hard to install and use. Oftentimes you need to install the entire mothership just in order to use a tiny feature. And you can only do a fixed number of data integration workflows. There's no flexibility there. Now, in the last 10 years, there actually have been some hope. There have been ecosystem of tools in Python and R. You are probably very familiar with tools like Panda, scikit-learn, matplotlib, and so on, right? So this whole ecosystem, for example, is called PyData. So these are free. They are very easy to install and use. You only install the packages that you need. You can flexibly combine them to support many different workflows. So they are very popular, but they offer very limited support for data integration tasks. So that is where we came in. Back in 2015, we started a project called Magellan. So this is named after the Portuguese explorer who traveled the Earth end to end for as the first person doing that. So our goal is to extend PyData with new packages to solve data integration tasks. And we started out focusing on entity matching. So entity matching is, like I mentioned, very simple problem. For example, suppose you're given table A describing a bunch of people like this, and table B. Now you need to find out that the first tuple in table A is actually the same as the first tuple in table B. They both refer to the same person. And similarly, the last tuple here and the last tuple here also refer to the same person. Very, very simple to state, but very, very common in data integration and very hard to do. Okay. So many solutions have done this, but they mostly try to automate everything. And that is not the approach that we took. What we did is this. We basically told the user, hey, if you want to match two tables A and B, you need to do it in two steps. You do it in development step and production step. In the development step, you take the two tables, you play around with the sample of the data, and you're gonna create a good EM workflow. So the workflow could have transformation step, cleaning step, blocking step, matching step. It will have some machine learning model also in there. And in this first stage, what we're gonna do is we're gonna give you a how-to guide in plain English. We're gonna explain to you all the individual steps you need to go through in order to go from the input table to a good EM workflow. Okay, so that could be step 1, step 2, step N. You may need to iterate back to step 2 and so on. So we will tell you what to do. Okay, and you're gonna do the step. Some of the steps will be easy. You can manually do that, but some of the steps will be very painful. It's a pain point. We're gonna develop some tool in Python, and you can use the tool to reduce your effort there. So that is what happened in the development stage. So after following the how-to guide, the user will have an EM workflow. Typically, the user will do this using some sample of data from table A and table B. And then the user will take the workflow and apply it on table A and B, and that will give the matches in the production stage. So in both cases, the tools will be developed on top of the PyData ecosystem. Okay? So our focus here is basically to reduce the user effort. We are not trying to automate the whole thing because we think that is just hopeless. This actually was developed since 2015, as I mentioned, and it was a pretty big effort involving 13 developers. This is now probably the most advanced open source EM system available out there, as far as I can tell. And we actually have also deployed it in many different places. So we deploy it in a bunch of companies for data scientists in those companies to use. We also deploy it for domain scientists at the University of Wisconsin to use. And we use the system to do a bunch of different matching, matching store, matching supplier, matching the rack, and so on. Magellan was also used by Amazon Informatica and by a bunch of students in different universities. Okay? So Magellan was quite promising, but there's a problem. It still requires the user to know Python. And many citizen data scientists don't know Python, right? So that is where we started developing the second system called Cloud Matcher. So Cloud Matcher doesn't assume that the user know how to program. It doesn't even assume that the user know what entity matching is. It just requires the user to label tuple pair as match and no match. So if you look at this picture down here, the user will just upload two tables, A and B, to the cloud. And then the user will label tuple pairs. The system will use the labeling data to learn rule for matching, and then eventually return the matches. And that's it. So as a very simple demo, you would go to the front page of Cloud Matcher. You create an account. You would log in, and you would upload two tables to be matched. For example, these two tables talk about restaurants. Okay, so every single row is a restaurant. So once you have uploaded the data, then the system will come back and ask you to start labeling tuple pair. So if you look at this first tuple pair, then it looks identical, except the font is a little bit different. So yes, it is a match, right? The second one, similar, is a match. The third one is clearly not a match, and so on. So you would label a few hundred tuple pair like this until the system tell you, okay, stop. And then it will use the label data to learn matching rule and do the matching and then return the results for you. So it will tell you that, oh, this one is matching this one, and then this one is matching this one, and so on, right? So very simple. So data scientists could, I mean, citizen data scientists could easily use something like this. And then there's more. So on Cloud Matcher, you could run the entire system end to end, like what I just told you. But we also expose all the individual action that you could do. So for example, you could upload a file, you could take a sample, you could label the data, you could train a classifier, and then you could apply a classifier and so on. All this is a part of the EM workflow, but we will expose them. So if you know what you are doing, you could use this thing and you could do EM in a much more flexible way. Okay. So again, we deploy Cloud Matcher in multiple different places for data scientists in a bunch of companies, and then also for domain scientists at UW, for journalists at a non-profit organization and things like that. Cloud Matcher did very well. It outperformed 3 commercial systems. One of them actually was developed over 20 years. So it received significant commercial interest. We created a startup and it got 3 acquisition offers and was acquired by Informatica last year. So that was Cloud Matcher. Now Cloud Matcher only solve entity matching. Okay, so we started a project back in 2018 called Columbus, and this one basically generalized Cloud Matcher. Columbus is a cloud platform to help users solve a wide variety of data integration tasks. So let me go through this example a little bit. So let's say that you are a citizen data scientist and you work using a laptop on-prem. You could upload several files, let's say 2 tables to be matched to the cloud, right? And this is called C drive. It is a part of Columbus and it is on the cloud, right? And it will look exactly like a Google Drive. So you upload the files and it looks like you are uploading to Google Drive. So you could very easily share the files with other people in the same team or people anywhere else, right? And then there's actually an app store, like an app store on iPhone. And a bunch of people have created containerized data integration application, and they have uploaded this application. Okay, so now the user could very easily download the application and install on C drive, and then the user just invoke the application. So this one, for example, could be Cloud Matcher, and then it would basically operate over these 2 tables and do the matching. So it's a very simple. It is sort of like Google Drive plus the iPhone, right? And if you look at PyData, then it has packages. Here you have containerized apps. So it's a sort of like a PyData on the cloud. So this cloud is actually right now it is AWS, but it could be some other cloud. And so it could also use all the services available on AWS, like Athena, SageMaker, and things like that. So for example, this would be the C drive interface. So if you as an user, you log into C drive, you can upload a bunch of files and then you could share the files with anyone else, right? And then you could download and install a bunch of applications, okay? And then you could invoke the application on the files. And you could also write codes to combine the application and things like that. So the key property of Columbus is that it is very easy to set up. It is an open source, it's a free. You just need to run the cloud machines. it's a very easy to share data and computation. If you have existing code in Java, you could also just containerize that, and then you could just share. Very easy to call computation to combine and execute them in pipeline. And then it is easy to scale elastically by adding and removing machine, and very easy to collaborate. So currently, we actually have deployed it at UW-Madison for domain scientists to share big table on the cloud and allow other people to come in and query table easily. They also share model written in Fortran, which they could not share before, but now they could containerize and share. And then data scientists at Informatica have also used Columbus to quickly perform entity matching. So what are the lessons that we have learned? So we think that citizen data scientists usually have varying skill. They could be expert programmer or know a bit of Python or no programming skill at all. So to help them, we should develop multiple platforms like on-prem, cloud, maybe even mobile. On-prem, like a Magellan, requires some Python knowledge. Cloud, you could require some knowledge, programming knowledge, but it could also be completely hands-on, right? Mobile is where you could use to say label the data and do some tasks like that, right? This platform should be very easy to share data and computation on them, right? Very easy to execute computation and pipeline your computation. Easy for the user to move around different platforms, and there should be how-to guide on how to solve the data integration task end to end. So right now we are working on improving Magellan and Columbus and working with your users. Now, one slide before conclusion. So in terms of related work, I already said that most existing data integration to a standalone monolithic system, Magellan is very different because it's built as a set of packages on top of PyData. And now we start seeing similar effort coming up in the database community. And then we have seen data integration companies building cloud-based tool. That is a major trend right now. But a lot of these tools just look like you take on-prem monolithic system and you kind of put it on the cloud. Columbus is again very different from that. We're gonna build something that is on the cloud, but it's a PyData-like. It's gonna be like, you know, iPhone-like apps that you could very easily download and install and use. Both Magellan and Columbus try to focus on facilitating ecosystem of users to share data and computation, either on-prem or cloud, right? So with that, let me conclude. So I believe data integration is a major part of the data science pipeline and will become even more critical. There's actually not enough good data integration tool today for citizen data scientists. We have outlined a very promising agenda to address this problem. The key thing is that we're gonna build stuff that look like a PyData with, you know, multiple packages that a community of users could easily share and download and use. We have some initial successes, but a lot of work still remains. And that's it. Thank you.
Thank you very much. Thank you very much for the great talk. So is there anyone from the audience that want to ask a question to our speaker?
Hi, Anhai. This is Mike Caffarella. How you doing?
Oh, hi. Hi, Mike. Long time no talk.
Yeah, I know. Hope you're doing well. Hey, so my question is, aside from kind of tool availability, what substantively do you think citizen data scientists do differently from the traditional corporate integration-driven workloads? Meaning like, there's a million examples out there of like company A buys B and they have to merge their HR databases. Do you think there's anything in terms of the workload that differentiates the two, or is it simply access to resources?
That's a great question. I think there's a significant differences, right? Since I have been at Informatica for 2 years now, so I get an idea on how enterprise customer work. And first of all, I feel like a citizen data scientist, they don't have a clue how to even start, what to do, what next step to take. So there need to be a lot more guidance, what I call how to guide, we need to tell them very clearly what they need to do, right? In an enterprise setting, you usually don't have that problem because a company like Informatica actually has a bunch of other satellite companies that are consultant, and they provide great support to enterprise customers. Citizen data scientists don't have that, right? The second thing is that, we need to develop tools that are very easy to use for citizen data scientists. And the problem there is that even the step of downloading and installing and making it run and understand how it works is already very, very hard for people. So this is why we want to break it into smaller pieces so that people could just download something basic and use. It sort of reminds me of when people just try to do a basic SQL query over a table, they don't want to download PostgreSQL, right? They want to download pandas. And that makes all the difference. So in a sense, if we really want to help citizen data scientists, we need to think like that. They should not have to download a big giant mothership. Does that answer the question?
Are there? Yeah, seems yes.
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 Yeah.
Are there any other questions from the audience? So if I actually have a question, and when you were describing Cloud Matcher, right, and you were showing to the users essentially a positive or negative response, like how did you measure when they had to stop? Like, is there like a measure of convergence of when the system is good enough and learned enough to have the user stop?
Yes. Very good question. So yes, so in active learning, you could actually measure whether the machine learning. So basically, when the user do the labeling, we actually use a technical active learning underneath in order to train a machine learning model. And we could measure when the model seem to have converged. So over 3 iterations, it doesn't seem to make any significant change. Then we recommend to the user that you could stop here or you could continue. There are some other ways to measure when the accuracy has reached a certain level, and then you could recommend stopping. For most data set that we have worked on, we need to label no more than 600 to 800 examples, and usually that takes an hour to 3 hours.
All right. Thank you very much for the answer, and thank you for the great talk.
Thank you. Yeah. So there's actually also a question on the chat. Do you see that?
Can you read it?
Yeah, so the question say, I want to know how the system that you introduced could help CS students who already know how to code. Should I answer that or should I take it offline?
You can give it a quick shot.
Yeah, so, Magellan, for example, is a system that actually helps computer science students who already know how to code, because you do need to know Python there, right? Just because you know Python doesn't mean that you know how to do entity matching end to end. So something like a Magellan will still gonna help you there. At the end of the day, it's a trade-off. If you know how to code and there's a clear guidance, you could do a better solution. That's it.
All right, awesome. Thank you.